All right, so now that we've classified matter as anything that occupies mass or occupies space and has mass, and that we could classify it as a solid, a liquid, or a gas, or that it has different phases, let's take a look at the properties of matter. We could classify it based on physical properties or based on chemical properties, right? And chemical properties, we're also considering if that particular molecule can actually react with something else. So what exactly are physical properties? There are changes due to surrounding conditions. An example is adding or removing heat. Ice melting is one example when you're adding heat to ice. In chemical properties, we're looking at how that particular substance can actually react to form something new, a new substances, and we call those chemical reactions. And we're looking at chemical properties, all right? What happens to the atoms in a given molecule when a chemical reaction takes place? And it involves rearrangement of the way the atoms are forming the bonds, right? It doesn't change the number of atoms, it just rearranges it. So an example is burning of methane. Methane has the chemical formula CH4, meaning it has 4 hydrogen atoms and 1 carbon atom, right? It has 1 carbon atom and it has 4 hydrogen atoms. Well, when methane is burnt, it's going to form carbon dioxide and water. Carbon dioxide has 1 carbon atom, 2 oxygen atoms, and water has 2 hydrogen atoms and 1 oxygen atoms, right? In this case, we're not considering what burning is adding to it, but it's forming something else, new substances, and we call those chemical properties, right? And the chemical identity of a given substance is really not altered by its chemical or physical properties, right? Carbon is still a carbon atom, whether we're looking at it in methane, whether we're looking at it in a different molecule, all right? And that's what we mean by that. The identity of the element is still the same. So what are physical states, right? They're results, we said physical properties or physical states, changes in physical states are a result of changes in the surrounding conditions. And we gave the example of temperature. The other physical properties that we could think of is the mass of something, its density, its color, its melting point, its boiling point. Can we identify something by its physical properties? We should be able to, right? By mass, density, color, melting point, boiling point, and so forth, right? Can we identify can we differentiate, for instance, gold, diamond, and water based on their physical properties? Yes, they have different colors, they have different densities. They'll occupy different mass in a given volume because of its densities, and the melting and boiling points are different as well. So those we consider physical properties, right? And it's giving you examples of the color. What phase does it exist in at 25 degrees Celsius? Diamond and gold are both solids, whereas water is a liquid. It's also giving you the density in grams per milliliter. Okay, so let's take a look at those two figures, or those two figures if we kind of separate them. On the left side, we have water, and water is between 2 phase changes. It's showing you water molecules in a liquid water right here versus in a solid. They really differ by one of the intermolecular forces that we refer to as hydrogen bonds, right? There's a little more hydrogen bond in ice, right? But those are physical properties. And the others on the right-hand side is showing us an image of atoms of liquid mercury versus liquid mercury when the temperature is 100 degrees. So what's happening is, as you know, it's being heated up, those molecules of mercuries are basically moving a lot faster, right? So as they're moving a lot faster at a higher temperature, they're occupying a larger volume, right? And if you think of density, it's telling you that the density changes. If you think of density, density is mass over volume, right? So when the molecules are moving faster, occupying a slightly larger volume, the mass is still the same, so the density increases. Those are examples of changes in physical properties, right? The identity of the molecule is the same. Water is still water. It just went from ice into a liquid, right? What are example of chemical properties? It's causing changes, think of it, that are irreversible. It's forming something else, a new substance. An example is methane. If methane is a gas, when it reacts with oxygen, it forms carbon dioxide and water, right? And there's heat that's generated. So carbon dioxide and water have very different chemical and physical properties than methane, right? So we call that a chemical change, right? Because there's changes in the chemical properties. Baking soda, for instance, if we put baking soda with carbon dioxide and water, or if you put baking soda and vinegar, it's going to form carbon dioxide and water. And if you touch that beaker, it's going to actually, it'll be cold to the touch, right? Because the reaction is actually absorbing the heat. So if we touch it, it's actually cold to our touch, right? And another example is reacting of copper with carbon dioxide and water, where it ends up forming a greenish blue substance. Right, so those are changes in chemical properties. What's happening when we look at a chemical reaction and changes in chemical properties? It has to do with the bonds between the atoms initially and how they're changing during that chemical reaction. So if we think of methane, all right, methane has the formula CH4. It's composed of one carbon atom, which is shown in black, and 4 hydrogen atoms, which are shown in like the grayish color. Oxygen is each of the oxygen molecules are composed of 2 oxygen atoms. Well, if we separate those atoms and we have another oxygen, then what we have is 4 oxygen atoms, 4 hydrogen atoms, and 1 carbon. And we're getting those from right here. So in a chemical reaction, what's happening is that the bonds are changing. So now we're forming, oxygen is forming 2 bonds to hydrogens. Each oxygen is forming 2 bonds to hydrogens, while carbon is forming bonds to oxygen, right? We'll learn later why I drew a double bond, but then we have water and carbon dioxide. So the overall properties of the new substances that are formed are different than the properties of the initial substances that are present. It doesn't change the identity that we have carbon and we still have carbon, we had oxygen, we still have oxygen, but the overall chemical and physical properties of the products are different than the chemical and physical properties of the reactants. The way they're connected, the bonds that are formed are also different, right? So it's a change, it's what we call a chemical change, all right? So we call those chemical properties. Can we alter the chemical properties of water? We said we could alter its physical properties by adding or removing heat. Yes, we can actually, we can have a chemical change when we apply an electric current and separate water into oxygen gas and hydrogen gas. So that would be an example of a chemical change because we're altering the chemical properties. It's becoming something else, right? So now we have 2 examples right here, right? And what you want to do is think, is what's taking place a chemical change or a physical change? So let's take a look at the one that I circled, right? think of what is happening when you go from the initial square to this square, right? What exactly is happening? Is it a chemical change or is it a physical change, and why? Right? And then take a look at the second one at the bottom. What is taking place when you go from the left to the right? Is it a chemical change or a physical change? How can we differentiate? Well, in chemical change, the original atoms or molecules or compounds are forming new substances. So the bonds that are formed, so basically bonds are being broken and new bonds are being formed. And we call that a chemical change. And a physical change, it has to do with changes that we could determine based on increasing the temperature, decreasing the temperature. We can identify physical properties by looking at mass, density, and so forth. So, but what's happening here, is it a chemical change or is it a physical change? Yeah, so if we think about it, you could think that all of those, let's say, molecules are floating. So think of them as being a gas, for instance, and on the square to its right, perhaps the blue are still a gas and the red became a solid or became a liquid, right? So suppose when the temperature is cooled, only the red atoms, either liquefied or solidified, they underwent a phase change, whereas the blue one didn't. So would that be chemical or physical change? Yeah, that would be an example of a physical change. Now let's take a look at the bottom figure. You had two blue atoms forming a bond or connected to one another, red atoms connected to one another. At the end, you had each red is connected to one blue. Yes, you do have some blues that are still unconnected, but would we consider that a chemical or a physical change? Correct. We would consider that as a chemical change. We're changing the identity of those substances. All right. So physical changes can be reversed easily. All right. Adding heat, removing heat, and so forth. Chemical changes are forming new materials, molecules or compounds, different from the original materials. Again, molecules or compounds, right? But the identity of the substances is not altered. We're simply altering its chemical or physical properties, right? Water, for instance, is still water, right? Carbon is still carbon. We're just altering its chemical and or physical properties. It's another example of a physical change. Here it's showing us some potassium chromate, right? At room temperature, when it's cooled, it's yellow. As heat is applied, right, what happens is that it becomes this deep red color. But once it cools down back to room temperature, it's yellow again. So could we consider that a chemical change? No, we would consider that a physical change. Why? Because we could go back to the original state of the molecule, right? It would have back again its original chemical and physical properties. So we call that a physical change. Is that always true? No, it could differ. So another example is heating ammonium dichromate. It changes to ammonia, water vapor, and chromium oxide. But what happens in this case, that's originally this deep red, and as it's being heated, right, it's generating water vapor, ammonia, and chromium oxide. And then once it cools again, it basically becomes something else. So it does not go back into its original state. So we call that a chemical change. A chemical reaction took place. It's irreversible. So now let's classify. Can we classify each of the following as physical or chemical changes? When wood burns to ashes, would it be a physical or a chemical change? Can we reverse it? Can we take the ashes back into wood? Correct, we can't. So that would be an example of a chemical change. Right? I'll just say CMP. Water begins to boil. If water begins to boil, right? Suppose you have, a cover on it and it condenses even into water vapor. I mean, water evaporates and condenses back. Is it changes in the chemical? Is it a chemical or a physical change? Yeah, exactly. It's still water. So it's just a physical change. We're adding and removing heat. We're not changing the identity of water. It's still water. Not changing the chemical identity of it, right? When grass grows, is it changing? Is there something happening to allow the grass to grow? Yeah, so it is considered a chemical change. It's also, we could see it, right? So we could physically see that it's changing, but it involves a chemical change for it to grow. What about if we have a piece of rock and we crush it into powder? Is this powder still the rock if it's simply crushed? Yes. So we're simply changing it. We're not changing the chemical identity of it, just the physical state. So that would be an example of a physical change. Okay, so now iron, it's telling you that it weighs more after it rusts. Okay, when iron rusts, can you reverse it? Can you take that rusted iron back into that rust back into iron? No, we can't. All right. Would we expect that the volume is changing, that the rust contains more iron atom, or that there's oxygen in it, or that it weighs less? It's already telling you that it weighs more, right? And what causes it to rust? Are we adding more iron on it? No, it's reacting with oxygen, right? It's reacting with oxygen and water, and it causes it to rust, right? So that's just something to think about, nothing that you would be asked of something like that, all right? But it's different. The idea is that it's a chemical change, right? The bonds that are present are different and the way they're connected. All right. I hope this was helpful. I'll see you next time.